Good morning, students. Today we are going to discuss the Kirchoff's law. Kirchhoff gave two laws by which we can determine the distribution of current among the different conductors of a complicated circuit. Now first we will discuss the Kirchhoff's first law. Or this is also called the junction rule, junction law या junction rule. Junction law. Kirchhoff states that in an electric circuit, the algebraic sum of the currents meeting at any junction in the circuit is 0. Means, suppose it is a junction suppose I1 current is going along the junction, I2 and I3 is going out from the junction, I4 is going out from this junction, and I5 is also going out from this junction. Then according to Kirchhoff's law, the algebraic sum of all the currents meeting at O will be equal to 0. On applying this law, the currents entering the junction, the current which are entering the junction is taken as positive, while the currents which are coming out from the junction is taken as negative. Means, from Kirchhoff's first law at point O, we can write I1 plus I2 minus I3 minus I4 minus I5 is equals to 0, or I1 plus I2 is equals to I3 plus I4 plus I5, or these are the incoming currents and I3, I4 and I5 are the outgoing currents. So we can say incoming current is equals to outgoing current. This is Kirchhoff's first law, which is also known as Kirchhoff's current law. Kirchhoff's first law is a statement of conservation of charge. Conservation of charge. Now we are going to discuss the Kirchhoff's second law, which is also known as loop law. It states that in any closed loop of a circuit, the algebraic sum of the products of current and the resistances in each part of the loop is equal to the algebraic sum of EMFs in that loop. Means, mathematically it can be written as sigma IR is equals to sigma E. And Kirchoff's second law is simply a statement of conservation of energy. Here in figure I have made a diagram in which we will apply the Kirchoff's law to calculate the current. In first loop I have made the direction of, like, the direction is this, and for second loop we will go in this direction. For first loop, applying the Kirchoff's law, I1 into R1 minus I2 into R2 is equals to E1 minus E2. As we are moving in this direction and I1 is in the direction of our movement, so I1 is taken as positive, while we are moving in this direction and I2 is moving in opposite direction, so we have taken it as negative. Similarly, we are going in this direction and E1 is along our direction, so it is taken as positive, while the E2 is opposite to our direction, so it is taken as negative. Similarly, for loop, this is for loop 1. For loop 2, the equation will be, we are moving in this direction, so here the current is I2 and the resistance in this part is R2, so I2 into R2 plus the current flowing in this resistor R3 is I1 plus I2, so I1 plus I2 into R3 will be equal to the EMF source present here is of E2, so it will be equal to E2. From these equations we can determine the values of current in different part of the circuits. So Kirchoff's second law is also known as Kirchoff's voltage law or KVL. So